back to my channel. In today's video, I'm going to be teaching you how to solve a system of 3 equations using the elimination method. You should note there's also a matrix approach to this, but I'm going to be making a separate video on that. Alright, so when you're using elimination, your first goal should always be to simplify your system of 3 equations down into 2 equations where you eliminate one specific variable, right? So in this case, that variable for us that we're trying to eliminate is going to be z. So let's identify z. And the next thing that we want to do is you basically want to pair off this first equation, so equation 1 with equation 2, and then equation 1 with equation 3. So we just write equation 1 and 2 over here, and we have equation 1 and 3 right here. Okay, so the next thing that we can do is we can just rewrite them right here. So this right here is equation 1, and then equation 2 rewritten is going to be right here. Alright, so the next thing we want to do is, since we're eliminating z, we're going to look at the coefficients of z. So we have a 2 and a 3. We can just ignore this negative sign for right now. And so we look, what is the least common multiple of 2 and 3? That's going to be 6. So basically we just multiply each individual equation by a number that's going to get us that least common multiple, right? So in this case it's going to be 3, in this case it's going to be 2. And yeah, you just want to make sure that you add a negative sign accordingly, because you want them to eliminate when they vertically add, okay? So in this case, we're just going to distribute this number right here, and then 2 distributed is going to give us this. Alright, so now when we vertically add, you're going to see that we have a negative 6z and a positive 6z, which added together are going to equal 0. So that's what we're aiming for. Now when we add everything else, we're going to get 9x plus y is going to equal a 34, right? And so this is our new simplified equation, right? And so we're going to do the same thing with equation 1 and 3, so we're just going to rewrite equation 1 right here, and then equation 3 right here. Right, so again, we're going to look at the coefficients of the z variable that we're looking at, and we have 2 and 8. Least common multiple between those is actually going to be 8. So all we have to do is multiply this first equation by 4, and that's going to give us a negative 8c, which is going to cancel out with the positive 8c. So let's just distribute this 4 right here. Minus 8c is going to equal a negative 64 right here. So when we vertically add, this is going to become 0, and then we're going to get 26x plus 17y is going to equal a negative 16, right? So now all we can do is let's rewrite our system, which is now consists of 2 equations instead of 3. Right here, and then 19x plus y equals 34. Alright, so now we have a more traditional system of 2 equations, which is much easier for us to deal with. Now when we're given this, we should look at which variable we want to eliminate. Let's just choose to eliminate y in this case. So we could just multiply this bottom equation by negative 17, but just to break it up, we can multiply this by negative 1 and then the bottom by just a positive 17, right? So now if we can write it over here, this is going to become negative 26x minus 17y, which is going to equal positive 16, and 19 times 27 is going to equal 323x plus 17y, and then 34 times 17 is going to equal 578. Alright, so again, when we vertically add, these are going to cancel out, and then right here we're going to get a 297x, which is going to equal a 594, right? So we simplify x down, and x is going to equal 2. Right, so this is our first answer. Now to find y, all we have to do is plug this x in into this equation right here. We can do either this equation or this equation. I'm just choosing the easier one, which has less terms, equals 34. And then y, which is going to equal 34 minus 19 times 2, which is going to be 38. So essentially y is equal to a negative 4. Alright, so now that we have 2 values, we can plug these 2 values into one of our original equations. In this case, we'll just plug it into the first equation, alright? So this means that it's 5 times 2 plus 3, negative 4, minus this 2z, which is still unknown, equals negative 16, alright? So from here we just simplify, and this is actually going to become a negative 12 minus 2z equals negative 16. We simplify again, and this is just a negative 2 So from here we can isolate our z, so we add 2 to both sides. And from here we know that z is going to equal a positive 7. Right, so from here on we can just create a ordered triplet, I guess. So we have 2, our y value, and then we have our z value right here. Okay, so pretty simple now. Alright, so let's continue moving on. That we've got our answer. So let's move on to our next problem. So we have this equation right here. So again, we want to simplify this down. So the first thing we want to identify is which variable do we want to eliminate, right? And we need to eliminate z. Let's just choose z again. So let's identify z. And let's pair these equations off with each other. So let's take equation 1 and pair it with 3. And let's take equation 2 and pair it with 3 as well. So again, it doesn't matter which equations you pair with each other, you just have to get each equation paired with another equation. Oh, I'm so sorry about that. Alrighty, so now that we've done that, we can just rewrite equation 1 right here. So we get 24x minus 30y plus 36z equals a negative 49. And then we also have equation 3 right here, which is going to be 8x plus 12y minus 6z equals 28. Alright, so from here, all we have to do is identify what we have to multiply by so that we can eliminate our z. So I think the only thing we have to do is multiply our bottom equation right here by 6, and we should be able to eliminate. Because this is going to turn into a negative 36c, which vertically added is going to cancel out with the positive 36c. So when we multiply, we're going to get a 48x plus a 72y minus that 36c, and then 28 times 6 is going to equal 168. Alright, so it's going to be a little hard to tell, but we're just going to vertically add this equation. So we can actually kind of eliminate this right here. Alright, so now if we vertically add these two, these are going to cancel out. And we're going to get a 72x plus a 42y. These obviously equal 0, and then when we add these two, so negative 49 plus 168, we're going to get 119. Alrighty, so let's continue moving on and do the same thing with this pair right here. So we have equation 2, so 16x plus 33y minus 6z equals 23, and we take equation 3, so that's 8x plus 12y minus 6z equals 28. Alright, so now that we've done that, obviously our least common multiple between these two is just going to be negative 6, or it's going to be 6, sorry, so we just have to figure out how to do the negative 6 version. And let's just multiply the bottom by, honestly, let's just multiply the top by negative. Right, so then we get a negative 16x minus 3y plus 6c equals a negative 23. Vertically add up together. Then we're going to get a negative 8x plus a 9y equal a positive 5. Alrighty. And just for the sake of this, I want all positive variables, so let's just multiply this again by a negative. So we get 8x minus 9y equals a negative 5, okay? So now let's go up here and rewrite our new system of just 2 equations. So again, we have 8x minus 9y equals negative 5, and we have 72x plus 42y equals 119, alright? So from here, let's just choose a variable that we want to eliminate. In this case, I choose that we should eliminate we eliminate x. So when we rewrite this over here, I think the only thing we have to do is multiply this by a negative 9. If we multiply by a negative 9, it should cancel out. So we have a negative 72x plus 81y is going to equal a positive 48, or 45, I'm sorry, and then we just rewrite this equation right here. Vertically add, these two cancel out, so 81 plus 42 is going to equal 123y, which is going to equal 164. Alright, so when we do this, 164 divided by 123 is actually going to be a fraction. It's going to be 4 over 3. It's a fraction. So this is what y is equal to. Alright, now to figure out what x is equal to, we could just plug it into one of these equations. So let's just plug it into the first equation right here. So 8x, x is still unknown, minus 9 over 1 times 4 over 3, y equals negative 5. Alright, so then we just get 8x. I'm sorry, why did I put y? Sorry. We didn't need to put y, I'm sorry. Minus, these two are going to cancel out. So minus 12 equals a negative 5. So 8x, if we add 12 to both sides, negative 5 is going to turn into a positive 7. So that means that x is just going to equal 7 over 8. Right? And that's what x is equal to. Now to figure out what our z is equal to, we just plug the x and y values into an original equation. So let's just plug it into equation 3, as this has the least terms, I guess you could say. So we just put 8 over 1 times this 7 over 8. And when I'm multiplying, I like to put these as like fractions. It's easier for me to comprehend. And then 12 over 1 times 4 over 3 minus our unknown 6z equals 28. All right. So I like to do this because you can clearly see that these are going to cancel out and these are going to cancel out. All right. So now when we do this, we have 7 plus 16 minus 6z equals 28. This together combined is just going to be 23 minus 6z equals 28. And we subtract 23 from both sides, we get negative 6z equals 5. That means that z is equal to negative 5 over 6, right? Because we just divide by the negative 6. All right, so when we combine all these, our ordered triplet, we could say that is going to be 7 over 8, comma, 4 over 3, comma, negative 5 over 6. All right, and that is our answer. Alright, so thank you guys so much for watching, and stay tuned for that matrix approach video that I'll be posting soon under my Algebra 2 playlist, and check out the other videos in that playlist as well. Thank you guys, and make sure to subscribe.